Welcome to the one class. This is your notes for section 2.8, modeling using variation. So when we do these variation problems, it's going to be anywhere from 1 to 4 of these steps. Okay, some of them we literally all we have to do is just translate it from from English to math, and then sometimes we have to solve for k, figure out what k is, and set up an equation. Alright, so that would be the first three, and then, but typically, like a full problem, we have to actually come up with the equation, and then actually model it, estimate a value for another set of values. So anywhere from 1 to 4 step problems here. Alright, definitely of the things you've been doing, one of the easier ideas, easier concepts, and kind of set up what we're going to do later in chapter 7. Alright, if you see direct variation, if you see something varies directly with some other variable, then that means you're going to set up something that looks like this. One variable is equal to k times the other variable. Alright, so when you see y varies directly as x, that means y equals k times x. Alright, so think of this varies directly as equals k times. So varies directly as is equals k times, and then the y is in front and the x is in the back. Y equals k times x. Alright, and we call k the number that we use to multiply by x. In this case, constant of variation. Kind of sounds like an oxymoron, but it's the constant thing that's in this variation. Okay, x changes, that causes y to change. That's the variation we're talking about. But k stays constant, meaning that when x changes, we're always multiplying it by the same thing to get y. Alright, sometimes it's called the constant of proportionality. Alright, so look at this phrase. Here again, I'm seeking out varies directly as. Varies directly as. Remember that we said that's what's going to be the equals k times. So equals k times. Alright, well what's in front of that? B. So B equals y equals, right, k times weight W. Right, as x, as weight. Okay, so B equals k times W is what we set up with this one. So there's the setup. B equals k times W. And then it says a person who weighs 160 pounds. Okay, that's weight, so that's W. So I'm going to change that to 160. Has approximately 5 quarts of blood. Alright, that's 5. Alright, and then it wants us to estimate the number of quarts of blood of a person who weighs 200 pounds. Well, first of all, we need to solve for k. So I'm going to divide both sides by 160. And then 5 over 160 will reduce to 1 over 32. Okay, 160 divided by 5 is 32, so we get 1 over 32. So that's k. So now I know exactly what k is, so I'm going to substitute this in for that k. I got b equals 1 over 32 times w, or you could write it as b equals w over 32. Alright, then part 2 says, now take this equation and estimate the number of quarts of blood, estimate b, if the person weighs 200 pounds. Well, if their weight is 200 pounds, that means W is 200. So that's telling me just take 200 and divide it by 32. And I get 6 1/4. So B is 6.25, and that was quarts of blood. Okay, so that's the 4-step process. Step 1 is translate it. So there was step 1. We got this translation. Step 2, solve for k, figure out what k is. Alright, step 3 says take that k, plug it in to the original equation that you'd set up in step 1, plug the value you got for k in for k. Right? I just rewrote it this way. And then step 4 says plug in some new values to solve for any other unknown variables. So that's the 4-step process. But like I said, some of them are going to be as simple as, here's a sentence, translate it into a statement or an equation. And then some of them will say, here's a sentence, here's a little bit of information, solve for k. Right? But if you see a number for one variable, a number for a different variable, and then another sentence where they're asking you to find one of these two variables given some more information about another, then you're going to have to do all 4 steps, which is the most typical type problem. Alright, now sometimes direct variation is not just one variable, to be direct variation to a power of another variable. So we may say y varies directly as the blank power of x. Alright, sometimes like we'll say the square of x, so we'll mean x squared, the cube of x. Alright, but then we'll say things like 5th power, 6th power. We only say basically squares and cubes. Everything else we'll just say the power. Alright, so if you see here it says the distance that a body falls from rest varies directly as, so there's the k times, right, equals k times. What's in front of it? Distance, which we're using s for distance. And then over here, after the varies directly as, is the square of time. So time squared. So s equals k times t squared. So s equals kt squared. And then we have the same type of info that we had before. If they fall 64 feet, that's a distance unit. So 64 equals k times, in 2 seconds, 2 squared. How far will they fall in 4.5 seconds? Well, before we can do that, we've got to figure out what k is. So 64 equals 2 squared is 4, so 4k. Divide both sides by 4. We get k is equal to 16. Alright, so now we go back and we rewrite the equation. S equals, there's the k, so k is 16, so 16t squared. And then how far will they fall in 4.5 seconds? That's a unit of time. So S equals 16 times 4.5 squared. Now the second bit of information they give you, they can give you S or T. They can give you either one of these. You just have to be able to use some algebra to solve. Alright, 16 times 4.5 squared is 324. So S equals 324. And again, the units for S here are feet. Alright, so again, there's that process. Translate, plug in and solve for k. Take k and plug it into the original function. And then go through and solve given the other information that you have. Alright, inverse variation. So with direct variation, we multiplied x by k. If we have a situation where we have y varying inversely as x, so now the vary inversely as means we're going to do k divided by something instead of multiplied. The y's, it's going to be equals k divided by something, and then whatever's in front is what we set it equal to, and then what's ever after the varies inversely as is what's going to be down here in your denominator. So y varies inversely as x means we have division. Alright, so direct variation, multiplication, inverse variation, division. So you use a can of hairspray, press the valve at the top, you decrease pressure of the gas in the can. Alright, this decrease the pressure in the can causes the volume of the gas to increase. Alright, a lot of information, but really everything's going to come right here. The part of the question that says varies inversely as. Alright, varies inversely as means we have equals k divided by something. What's in front of that? P. What's after that? V. So there's our setup. There's our translation. The pressure, P, if it's 8 cubic inches, but sorry, I got that back. The volume is 8 cubic inches. The pressure is 12 pounds per square inch. Okay, and now instead of dividing to get K, I multiply to get K. So 8 times 12 is what I multiply to get K, so K equals 96. Alright, now I plug that in back into this equation. P equals 96 is K divided by V. Alright, and now I use that to answer the other question. If the sample expands to a volume of 22, what's the new pressure? P equals now 96 divided by 22. I get 4.36 roughly pounds per square inch. So there's an inverse variation problem. Same concept, except the setup has division involved, and because of the division we end up solving it a little bit differently. But it's the same concept. And then if we have combined variation, we can have direct and inverse variation occurring simultaneously. So you just read through it and you find those phrases: varies directly as and inversely as. So the vary directly as means we have K times something. Okay, the inversely means we have K divided by something. Now we don't put K in there twice, because the constant that would cause the direct variation and a constant that would cause inverse variation, they're being multiplied together and creating another constant, so we just use K once. Alright, so remember what comes before the variation, the varies directly, varies inversely, is on the other side of the equals by itself. After the directly as is A, the advertising budget, and then after the inversely as is the price, P. Then 60,000 spent on advertising, that's A. That's going to be, I'm going to write it after the K after that number, so 60,000 K. The price, P, is $40, and the sales are 12,000. There's our setup to solve for K. Alright, so 60,000 divided by 40 is 1,500. Then I divide both sides by 1,500. And I'll have K by itself. Alright, so that means K is equal to 8. And now I go back to this, and I write the K replaced with what we got for it. So 8A over P. Okay, so writing the equation, the variation describes the situation. That's this right here. A. So there's part A. Alright, and then determine the monthly sales. The amount of advertising budget is increased to 70,000. Alright, the advertising budget is now 70,000. So this is B, and the price that it say we're changing it, so we're going to assume it's still $40. Alright, so 8 times 70,000 divided by 40 is 14,000. So there's what we get for our answer when we do the second part. Alright, combined variation just means direct and inverse. When you see those phrases, it means you're going to have multiplication and division to go on in this problem. Alright, and then joint variation typically means we have very direct variation between more than one variable. So y equals k times x times z is y varies jointly as both x and z. Okay, so when you see joint variation, we are direct variation between more than one variable. Alright, centrifugal force. We got something moving around in the circular path. There's the radius of that circle. There's the mass of the thing that's going around on that circular path. It varies jointly with the radius and the mass, and inversely with the square of the time that it takes to move one full rotation. So there's the varies jointly, and then there's the varies inversely. So jointly means we're multiplying, so equals k times. Inversely means we're dividing. Alright, jointly means we're multiplying by two things, or two or more. So radius and mass, so r and m. inversely with the square of the time. So t squared. Right, and that c is what's in front of the variation. So c equals all that. So there's our setup. And then we have some information to let us find k. So a 6 gram, alright, that's a mass unit, so that'll be 6 right there. Moving in a circle with radius 100 centimeters, so the radius is 100 centimeters. At a rate of 1 revolution in 2 seconds, so it takes 2 seconds. We square that to make 1 full revolution. So that gives me everything I need to solve for k. Alright, all this that's being done to k over here, I can do it all at once on the calculator, just 100 times 6 and then divided by 2 squared. So 150 is what's being multiplied by k. Alright, and then I divide both sides by 150. 6,000 divided by 150 is 40. So now I know k is equal to 40. Alright, and then I go back to this original equation, c equals 40 rm over t squared. Alright, and that's my equation that I used to do the second part. So find the centrifugal, find c if we have 18 grams, so 18 is my mass. Moving a circle with a radius 100 centimeters again, so 100. If it takes 3 seconds, so we slowed it down a little bit, so 3 squared. So again, I can multiply all that in here at once. Alright, you don't need this parentheses, but if you're ever concerned, because sometimes you do need parentheses, just put numerator in parentheses and the bottom in parentheses, but you don't have to have it. Alright, so 8,000 is our 8,000 dynes is our force. Alright, so there's the different types of variation that you'll see in this section. Direct and inverse, if you just see those, that means you've got just division or just multiplication. But when we have the combine and the joint variation, we have more than two things that vary together.